Hello, lovely student. Welcome to my lessons on strings, lesson 7. Today we're going to be looking at specifically how do we handle characters. So we all know that we can declare a character variable, that is, a variable of data type char. Note, we do not say character, but instead the data type is char. By convention, we use the prefix C when declaring a character variable. A character could be a single character, a single digit, or a single punctuation mark. It could be a special character. These characters are written in single quotes. I've created a variable called C input, and I've assigned the capital letter A to this variable. I'm then displaying the value stored in the variable on a label. In this example, I'm using string literal, using the plus operator to concatenate and join the character variable to a string literal. In this example, the output will read, A is my character because A is stored in the variable C input. ASCII stands for American Standard Code for Information Interchange. Again, American Standard Code for Information Interchange. The ASCII table now consists of 256 characters. The first 32 characters are not visible on screen, and the next 95 characters are visible on screen. Computers store all their data as binary, that is, as numbers. People realized that they wanted to store text, so they linked characters to numbers so that it can be stored. So let's look at the ASCII table. So on the ASCII table, the first 32 characters are not visible on the screen. So it starts off at 0 and it goes to 31. So if you look at the decimal number, there's a corresponding character and vice versa. So for the corresponding character, there's a decimal number. The common ones that we normally use is the cancel. So if you look on your keyboard, the cancel button on your keyboard, it performs a functionality but is not visible on screen. Another common one that we use is the escape key. It's right at the beginning of the keyboard at the top. If you press the escape key, it performs a functionality. Something escapes, it goes away. And that's the corresponding decimal value is 27. So these are the 32 keys that are not visible on screen, but part of the ASCII table. The next 95 characters are all visible characters that you see on screen. So if you look at a capital letter A, the decimal equivalent is 65, and the corresponding character value at 65 is the capital letter A. At 66 is the capital letter B. At 67 is the capital letter C. And it goes on, and at 90, it's the capital letter Z. Then you have a whole lot of special characters. the small letter A starts off at 97. The small letter B is at 98. And then you go all the way to a small letter Z, ends at 122. So these are your characters on the ASCII table that is visible on screen. So now that you are familiar with the ASCII table, let's look at the CHR function. CHR function. This function returns the character of a specified decimal value. So it takes an integer as its argument and outputs the character associated with that number using CHR. So on the ASCII table, the character of this decimal value 65 is a capital letter A. The character of the decimal value 66 is a capital letter B. And if I had to use 95, it should give me 97, it should give me the small letter A. So CHR again is a function. A function returns a value. I'm calling this function with one parameter that's being sent in as an argument to this function. The function then takes the value that is being sent in, which is a decimal value that's on the ASCII table, and it converts this value into a corresponding character equivalent. So if you want to get a character, you would, of a decimal value, you will use CHR. Ord function, ORD, is also a function. This function will take a character as an argument. So it takes in a parameter, which is a character as an argument, and it uses ORD to convert the character to an integer value. So the capital letter C on the ASCII table corresponds to 67 on the ASCII table. So if I want the corresponding character of a number on the ASCII table, I will use ORD. That will give me the number equivalent to the corresponding character. So again, ORD takes a character as its argument and outputs the integer associated with that character. Let's go and have a look at a program. So I've got an activity for you. Write a program that gets a character from an edit box. Create a button labeled Encrypt. When this button is clicked, your program must store the character from the user. It then encrypts the character by converting it into an integer, adding 1 to the value, and then converting this back into a new character. The output must be done on a memo, and an example of an output that is given. So if the letter A was entered via the edit box, it will display the letter B. Let's go and take a look at some Delphi coding and see how we're going to solve this problem. So on my Delphi program, I've created a project called Characters, a label that says enter a character, an edit box that is going to allow the user to enter a single character. I'm then going to display on a memo, and I've got 2 buttons, one to do encryption. So let's look at the encrypt button. So on the encrypt button, all I'm doing is I'm entering a character. I've created a variable for the character, which is called C letter. It's of data type char. I'm getting the character using an edit box. Remember that the edit box property allows you to enter text, which is a list of string. But I want to get the first character of that string. So to extract the first character, I would use square brackets, and at index 1 will be the first character of that text or string. And then I store it in a variable called C letter. I need to add 1 to that character. So there's your C letter. To add 1, I need to get the integer value equivalent to C letter. So if C letter was the letter A, which is 65, so what it will do is, using Ord, it's going to get the decimal value equivalent to this character. So if it was the letter A, it will give me 65. I then add 1, which will then give me 66. So 66 is the next character, which is the letter B. I then take the value, which is 66, and I'm using CHR to convert it to a character. And that would have given me the next letter. So let's look at it again. If the user entered the capital letter A, I need to encrypt it by getting the next character of the alphabet, which is the capital letter B. So I then use Ord to give me the value, the actual digits. And for the capital letter A, it's going to give me 65. To add 1 will give me 66. And 66 is the next character on the ASCII table. Using CHR, I then convert 66 to the character equivalent to give me the next letter of the alphabet. And then I display the letter, original letter, which is the first letter entered on a T-edit, and C next letter will give me the next letter entered, the next letter on the ASCII table. Let's run this and see how it works. So if I enter the character, let's use the letter A, and I want to encrypt it, it must give me the letter B. If I entered B and I encrypt it, it must give me C. I have another program that I'd like, a little segment that I'd like to work with you right now. So let's go into it, and this was the generate button. Let's call it generate. All right, and let's go and look at how am I going to generate a random character. So again, I created a character variable which is of data type char. And I'm generating a random uppercase character. Using random, which is a function of the math unit, I must call the randomize procedure. So whenever I use random, I must call the randomize procedure. So to generate a random uppercase characters, we know that on the ASCII table, the uppercase characters from A to Z starts at 65 and ends at 90. So using random, the first argument that is sent to the function random is your upper limit minus your lower limit, and you add 1 to it. So let's look at what will be the upper limit and lower limit. So if I want to generate a value between 65 to 90, so my lower limit value is 65 and my upper limit value is 90. So it's going to generate a capital letter A to a capital letter Z. So this parameter or argument that is being sent to the random function is 90 minus 65, which is going to give me 25, plus 1 will give me 26. And this, when you say plus, this value is always your lower limit value. So let's run this. The random character is C letter. It will generate a random uppercase character between capital letter A and capital letter Z. So this we could go and put in. It's going to generate capital letter A to capital letter Z. Let's run this and see how it works. So the generate key, and it's generated a random character between A and Z, which is the capital letter H. Let's try it again and see if we can change these parameters. So if I wanted to generate a lowercase value, so let's go with the lowercase value starting at 97 to 122. So I want to generate a value between 97 to 122. And what will that generate? A small letter A to a small letter Z. So it's a small letter A to a small letter Z. How would I change these parameters? This will remain at 26 because the difference between 97 and 122 is 25. 25 plus 1 will give me 26. This value will now change to the lower limit value. 97 to 122. 97 is my lower limit value and 122 is my upper limit value. So this value will now change to the lower limit value, which is now 97. Let's run this and see if it generates lowercase characters from the ASCII table. And remember what CHR will do? It will convert the value, the decimal value, to a character. That's what CHR function does. Run this. Okay, so when I run it and I say generate, it generated a small letter G, which is within the range of a small letter A and a small letter Z. Thank you, learners, for listening. Stay inspired, stay motivated, and follow me on my next video.